when we get into section 6.3, we're going to start talking about similarity, which is what the whole entire rest of this chapter is about, similarity. So back in chapter 4, you talked about congruent triangles, and congruent triangles means that all the sides are the same, all the angles are the same. Well, that gets a little bit different when we talk about similar polygons. Similar polygons are polygons having corresponding angles congruent and corresponding sides proportional. So polygons having corresponding angles congruent and corresponding sides are proportional. Key things. Angles are going to be congruent. You might want to underline that. Sides are proportional. Well, what does a proportion look like? Two ratios equaling each other, right? So sides are no longer going to be the same. If they were the same, then we'd have congruent polygons. Now we have similar polygons. So maybe on your index card, you might just want to write the word similar, and underneath it put angles congruent, sides proportional. As a little note of remembering what similarity means. You don't have to write this whole entire statement. I would just write angles congruent, because I know that all the angles are going to be the same, and the sides are proportional. So if we all went downstairs and smashed our face at the photocopy machine and hit print, right, that would be a 1-to-1 ratio, so they would be congruent. But what if I hit that enlargement button and blew my face up by 200%? Would the size be the same? No, it'd be bigger. But the angles, you could find angles in my face, that would be a little weird, would be the same, right? Okay, so similarity. Angles are congruent, but sides are proportional. Got it? All right, so our next vocabulary word is the scale factor. And your scale factor is the number that describes the change from an original figure to another figure. So we're going from the original to the new figure. Okay, so original to the new, original to the new, original to the new. Okay, when you set up your scale factor, you're pretty much setting up a ratio of the change from your original to another figure, or the new figure. Okay, so scale factor. Sometimes we use the letter K as our abbreviation. Oops, I'm in highlighter mode. Sometimes we use the letter K as our scale factor. Okay, so if you see a K, or if you want to use K, it asks you what's your scale factor, your factor is, and you write K equals, bless you, then you can use that for your abbreviation of it. All right, so we've got similarity, we've got scale factor. The next vocabulary word we have is a similarity statement. So you were professionals of congruent statements back in chapter 4. Bless you. Similarity statements still kind of look the same, except now we have a new symbol for similarity. So here I have triangle ABC. This is similar to your congruent sign, but what happened, we took away the equals underneath the squiggle. Right? Think back to what your symbol for congruence is. It's the equal sign with the squiggle atop of it. Well, now I'm taking away the equal part because I don't have all equal corresponding parts. So just a single squiggle is your symbol for similarity. So if you're asked to write a similarity statement, If it's a triangle, then you can just put the triangles in front and put the letters of the vertices. If it has 4 sides, then just list all 4 letters. If it has 5 sides, then just list all 5 letters. You don't need to put any type of symbol in front of those letters. My goodness. I guess you guys are allergic to similarity. All right, so here's our first example. Are the polygons similar? If so, write a similarity statement. So, to check for similarity, we need to first check to make sure, do we have congruent angles? Yeah, they're all 90 degrees. So I would say yes, we're good there. So that checks that box. Now we need to check, do we have proportional sides? Which means we need to set up a bunch of proportions. So, here we have a side length of 6. Here I have a side length of 8. 6 should technically match up with what length on the other rectangle? 14 or 10.5? 10.5. And the reason why it is 10.5 because it literally looks like the same shape, just bigger, right? But usually you check the smallest side with the smallest side over there. And those both happen to be the smallest measurements. So, I'm going to make a ratio out of 6 over 10.5. So usually, if you're not told which one is the new one, just work left to right. So, our original to new. So 6 over 10.5, and now let's compare it to the large. Is that the same as 8 over 14? Multiple ways on how you can check this. You could literally take 6 and divide it by 10.5 on your calculator and get a decimal. What is that? Someone do it. 6 divided by 10.5. 571. Now do the same thing for 8 divided by 14. So they're the same. So then I know I have proportional sides. Or we could just check cross products and see if they're equal. 6 times 14 is 84. If I do 8 times 10.5, I also get 84. So my cross products are also the same. Okay. Me personally, I do it this way, just in case if you have 3 sides, then you're not doing 3 different cross products. You can just do 3 divisions and make sure all the decimals are the same. So because I have congruent angles and because I have proportional sides, I'm going to say yes, my shapes are similar. And now I'm going to write a similarity statement. Well, it's not a triangle, so I don't need to put any symbols in front. So I'm going to go rectangle ABDC, I guess. So ABDC is similar to, what would be the order on the other side? Good. KMLJ. So there would be your similarity statement. So to check for similarity, do we have congruent angles? Do I have proportional sides? So let's do the same thing for part B. Can I erase this? Okay. So part B, check our angles. Bless you, man. Do we have congruent angles? Bad congruent sign. Do I have all congruent angles? Yeah. Yes. Check. This angle is congruent to that angle is congruent to that angle, T is congruent to G, so those all match up. Now we got to check our sides to make sure they're proportional. All right, so the smallest side on the left is what? Smallest side on the left is 5. Make it into a ratio with the smallest side on the right, which is 4. Now let's do the middle or the medium. So 10 would be comparable to 8. And then 12 would be comparable to 9.6. So now we just get calculator in hand. 5 divided by 4 is 1.25. 10 divided by 8 is 1.25. So far so good. Let's do 12 divided by 9.6. Guys, if you could stop the side conversations, I'd appreciate it. It's also 1.25. So are my sides proportional? Yes. So my triangles are similar? Yes. So I'm going to say triangle. Let's see if this works out. Did I really do cat and dog? CAT is similar to, C matches up with D, A matches up with O. Oh, I did. Look at that. Triangle cat similar to triangle dog. Okay? So, can you check if two figures are similar? Yes? Yes? Okay. Given, so let's kind of flip it. Here we were checking all of our corresponding angles to see if they are congruent, and we were checking that our sides were proportional. So now we're going to kind of flip that switch. Now I'm going to tell you that I have similar triangles. Can you list all of the corresponding parts? So let's start with the angles first. What angle would be congruent to angle R? Angle X. Because remember, angles are congruent, right? S would be congruent to angle Y, and angle T would be congruent to angle Z. That's nothing new. We've done that before. We did that back in chapter 4, right? Now what's going to be new is your sides, because now our sides are no longer congruent. Our sides are proportional, which means I need to write an extended proportion. So what would side RS be proportional to on the other side? XY. You're still looking for the corresponding parts. It's just now you're writing it as a ratio because they're proportional. Which should be equal to ST would match up with YZ. And then what's the last side that I'd be missing? I have RS, I have ST, so the third side would be RT. Good, 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 good. RT and XZ. Okay? So given a similarity statement, can you give me the congruent angles? Can you give me the proportional sides? Hopefully. Okay? All right. If you want to throw that on your index card, quick, do it. I would write that similarity statement right here, and then I would put your answers. If you have space, you should have space. So you have a brand new index card. Now we're going to get into scale factor. So now we are given triangle RST is similar to triangle XYZ. So now they actually physically put them there for us. We need to figure out what the scale factor is. So our scale factor, I'm going to use the letter K, is equal to your original over the new. You might want to put that on your index card. And label this K as your scale factor. So your scale factor, which we're going to use the letter K as our abbreviation. So your scale factor is equal to K, which is equal to your original over your new. So because I already was told that these triangles are similar, that means all of the sides should be proportional to each other. So I just need to pick two sides, one from the original and then the corresponding one to the new, and write it as a ratio. So do you like 20, 25, or 30 better? 20? Okay, so we're going to do 20 over, so what would be the corresponding one over here? 12. So 20 over 12. So now I just made a ratio. Can we reduce that? That would be, take out 4, so 5 over 3, right? So my scale factor would be 5 to 3. So for every 5 units, it's scaling down to 3 over here. Okay? So if you're asked to write a scale factor, you're just making a ratio of original over new. Yes?
Do you have to do it just for one, or do you have to?
Well, they would be the same. If you did 30 over 18, then I could take out, it would still go down to 5, so I could take out 6, so 5 over 3. So it doesn't matter which sides you use. Just make sure you use corresponding sides. Okay? And if the orientation of these triangles, meaning maybe this started rotating and it's not exactly in the same orientation, do you guys understand what I'm saying when I say that? So make sure you utilize RS matches up with XY. So that means I'm going to match RS up with XY. So make sure you utilize that. All right, next one. Now we're going to use our scale factor to solve for x. So again, I'm given similar triangles. I need to find x. X is on the length of NP. Up here, NP matches up with EF, right? So EF on this side is 20. So can you make a ratio? If I do 20 and then put it over x, that would work. Well, in order to be able to solve for x, I need a proportion so I can cross multiply. So now we got to do another set of sides. What side do you like the best? Do you like 12 or do you like 16?
Oh, 16. No, 12.
You want 12? It wouldn't. It wouldn't matter because I am given both. If this 12 wasn't here, then I would have to use the 12 and the 9, right? But since I'm given all of them, it doesn't matter. So now I'm going to do 12 over 9 or 9 over 12?
12 over
12 over 9, because I went left to right, which means I have to go left to right on the other ratio. So 12 over 9. Cross multiply. 12x is equal to 180. So x is equal to 12 goes in 18, 1, 60, is that 15? Did I do that math correctly in my head? So x is equal to 15, which this technically is your scale factor, right? Just not reduced. What would be the scale factor if I reduced it? 4 over 3, right? Because original over new. Questions with that one? All right, so now let's go away from triangles to a quadrilateral. So now I'm told that ABCD is similar to QRST. What is the scale factor? What's the scale factor? What ratio are you going to make? Good, so K is equal to 10 over 5 would work, which reduces to 2 over 1. Good. So for every 2 units, it's scaling down to 1 unit, right? Would you have gotten that with 16 and 8? Yeah. Would you got that with 12 and 6? Yeah. Okay. So now we're going to find the value of x. Can someone give me a proportion to get x? I mean, I guess do we really need to set up a proportion? That one's kind of easy. If this is 4, what would that have to be? Try again. 8, right? Because it's getting bigger going in that way. Or we could set up our proportion. We could do 10 over 5 is equal to x over 4. 5x equals 40. So x is equal to 8. Okay, and our last one. If AB is proportional, remember this is the same thing as a ratio. So AB to BC is 3 to 4. So we can rewrite that as fractions, right? So AB over BC. The word is always just a word for equal sign. 3 to 4. That kind of looks a little bit familiar to what we were just doing in 6.2. What is the length of AB? 6. Do I know BC? So put an x there, equals 3 over 4. Cross multiplying that gets us 3x equals 24. So x is equal to 8, which means BC is equal to 8. Okay, so you're just doing a whole bunch of proportions and ratios.